Okay, in this problem they want us to use cylindrical shells to find the volume of a solid obtained by rotating the region bounded by, in green I put y equals 6x squared, x equals 1, y equals 0. Okay, and oh, this should say rotate about. Rotated about the x-axis. We're rotating about the x-axis. So that's why I have that little arrow there. So I think I shaded the correct region. I wrote down the formula for using cylindrical shells in order to find volume. And I noted that I always have to remember the shell radius is the distance from the axis of revolution. So the axis of revolution is the x-axis, so if we're rotating it this way around the x-axis, the radius is right here, right? That's the radius of the shell. It's the distance from the curve to the axis of revolution. The height, we got to figure out the height. But also notice, if we're rotating around the y-axis, get the integral in terms of x. If you're rotating around the x-axis, which we are, get the integral in terms of y. That's why I wrote dy up there instead of dx. So we have to get everything in terms of y. In other words, we have to change this equation so it says x equals. So can we do that? We have y equals 6x squared, right? We want to get x all by itself. So I think the first thing we'll do is divide by 6, right? And then take the square root. So what do you get? Right? We get x is equal to plus or minus the square root of y over 6. We're on this side of the origin, so I think we're going to actually just have to use the positive one, right? Okay. So why do we need that? Well, we need that to figure out what the heck our height is for any particular shell, right? So do agree that the height, that distance from 1 is a distance from, like there's you could pick different shells. We happen to pick this one. But the height for this one is 1 minus what the curve value is. So the height is going to be 1 minus what's the curve value, right? So I'm just trying to get everything in terms of y, guys, okay? All right, I think we can finally do the integration. Okay, now remember, the limits on the integration are y's. So what does y go from? Y goes from 0 to, x is 1. So when you plug a 1 into 6x squared, don't you just get a y of 6? So we know that y goes from 0 to 6 for this bounded region, okay? 2 pi stays the same, thank God, okay? A radius is the distance from the axis of revolution. It's just that distance, and it's just going to be in terms of y. It's just some y value, right? And then what did we figure out for height? 1 minus y over square root of y over 6 dy. Whoa, okay. So let's try to figure this out. So now we just have to do the integration. So I put the 2 pi in front to make it easier. And then I distributed the y, guys. And I think I put, this is how I rewrote this. It's the square root of 1 over 6 times y to the what? You're multiplying y to the 1 times y to the half. You add the exponents, right? So it's 1 plus a half is 3 halves. So I did that because it'll make us easier for us to integrate now. Okay, so rate it with exponents. So I got a 2 pi. Okay, let's take the antiderivative. Antiderivative of y is pretty easy, right? Isn't it just 1 half y squared? Okay, minus, I got this constant square root of 1 over 6. What's the antiderivative of y to the 3 halves? Isn't it? You add 1 to 3 halves, that'd be 5 halves. So it's 2/5 y to the 5 halves, right? And that all goes between 0 and 6. Okay? We're getting there. All right, so let's rate it a little easier. let's distribute the 2 pi. So I have the 2's cancel out, so pi y squared minus, oh God, whatever that is. You know, I didn't even think I had to rewrite this. Times 2 pi. Right? Almost forgot the 2 pi. Ugh. So you can really mess up things. So what do we have? Now if we plug the 6 in, we get y times 6 squared minus 2 pi square root of 1 over 6 times 2 fifths times 36, 6, sorry, 6 to the 5 halves minus, thank God, 0, right? So then I did this on my calculator and I got 113. I carried it out pretty far for decimal points, and I did this whole thing on my calculator, and I got 90.477868, which gives me a 22.61947. I don't know how many decimal points they would want you to carry it out to in the problem that you're doing. But, okay, so you got to be careful. Main thing here is to realize we're rotating around the x-axis, everything in terms of y. So we had to do that in order to find the height. And then we had to plug everything in and make sure we didn't make any mistakes like I almost did, and plug it into your calculator and get the magic answer and type it in and hope that it's right. Okay? Hope that helps.